Good afternoon, and welcome to the third of three videos on an introduction to limits. All right. In this video, we're going to go through several examples and look at exactly how to calculate limits, especially using the rules that we talked about during the second video here. So we'll start with example number 9, which asks you to find each of 6 different limits. The first is the limit as x approaches 4 of x squared. And so you'll recall that for this one, this would be equal to the limit as x approaches 4 of x squared. All right, that's what this value would equal. Well, of course, the limit as x approaches 4 of x is simply 4. All right, and so that would give me simply 4 squared, which of course is 16. So easy peasy, right? And so that's using the power rule here. Now for the second one, we've got the limit as x approaches 4 of 5x, and that is the same as the product rule. So the limit as x approaches 4 of 5 times the limit as x approaches 4 of x, all right, which of course the limit as x approaches 4 of 5 is simply 5, and the limit as x approaches 4 of x is 4, and so the limit in this case is simply going to be 5 times 4, or 20. Okay, easy peasy. For C, I've got the limit as x approaches pi of the tangent of x over x. And so using the quotient rule, this is the limit as x approaches pi of the tangent of x divided by the limit as x approaches pi of x. And so in this case, the limit as x approaches pi of the tangent of x is the tangent of pi. And if you don't know, just plug it into your calculator, but the tangent of pi is 0. And of course, the limit as x approaches pi of x is simply the value of pi. But of course, anything over 0 over anything is simply 0. And so the limit here is 0. The limit for D, the limit as x approaches 9 of the square root of x. In this case, it is simply going to equal the square root of 9. And so that's going to be 3. That's just direct substitution here. This one is the product rule. So the limit as x approaches pi of x times the limit as x approaches pi of the cosine of pi. And so, come on now, please. I'll put that over here. So the limit as x approaches pi of x times the limit as x approaches pi of the cosine of x. Now, in this case, of course, the limit as x approaches pi of x is simply pi. And the limit as x approaches pi of the cosine of x, well, the cosine of positive pi is simply -1. Come on. -1. And so this equals altogether -pi. All right, so there's your answer for E. And finally, in this case, this is the limit as x approaches 3 of the quantity x plus 4 squared. And this is going to be the limit as x approaches 3 of x plus the limit, this is the sum rule, of as x approaches 3 of 4, and then using the power rule, we square the whole kit and caboodle. Well, the limit as x approaches 3 of x is simply 3. The limit of the limit as x approaches 3 of 4 is 4. 3 plus 4 is 7, and 7 squared is 49. All right, and so those are those 6 values. Okay, if any questions, again, make sure that you ask at our next Zoom meeting or via email. Okay, now a couple more rules that we should play with a little bit here. And that these deal with polynomials. So, x squared plus 2x plus 1, or, 3x cubed plus 2x plus 4, right? Those are polynomials. And so if p is a polynomial and c is a real number, then the limit as x approaches c of p of x should equal p of c. All right, and then we can use all of the rules for calculating limits that we talked about in the last video in order to do the calculations here. All right, so the limit as x approaches c of p of x will equal p of c if p is a polynomial and c is a real number. Okay. And the easiest way to deal with polynomials is simply to do direct substitution, right, rather than going through all of those rules. Now, for the one exception to this that we're going to make is that of rational functions. And the exception is that the denominator here cannot be equal to 0. And so if r is a rational function r of x, which is equal to the quotient of p of x over q of x, and c is a real number, such that q of c is not equal to 0, because again, you don't want a 0 in the denominator of the function because it makes it an undefined term. If that's the case, then the limit as x approaches c of r of x equals r of c, which equals p of c over q of c. All right. Now, that seems like a foreign language to you. It does to me as well. All right. However, it's fairly straightforward, and we'll do an example on the next slide just to illustrate that it's really not as crazy as it seems. All right. So let's have a look at then example number 10. You're asked to find the limits of two different functions. In the first, we've got the limit as x approaches -1 of x squared plus x minus 6. And rather than go through the power rule and the sum rule and the difference rule, all right, I'm simply going to do this by direct substitution. So x squared, actually, let me get rid of that. And so this is going to be -1 squared plus -1 minus 6. Well, negative 1 squared is 1. Minus 1 is 0. Minus 6 is negative 6. And so there is the answer for the first one. All right, easy peasy, right? You're just essentially substituting and then plugging and chugging. All right, so the limit as x approaches negative 1 of x squared plus x minus 6 is simply negative 6. Now, this one is the irrational function here. And the first thing we have to do is make sure that the denominator doesn't end up being 0. And it doesn't, right? If x approaches negative 1, we substitute negative 1 in for x. Negative 1 plus 3 is going to give me positive 2. So we're good, all right? Now, I already know that the limit as x approach, what is going on? As x approaches negative 1, x squared plus x minus 6 is equal to negative 6. Then if I plug in negative 1 here, negative 1 plus 3 is 2. And so the limit of this function is simply going to be negative 3. All right, and so there's my answer for B. All right, easy peasy. All right, so that brings us to the end of section 12.1 in your textbook, and therefore it's time for some homework. All right, and this assignment will be due at the beginning of your next class. I'm going to ask you to do the odd numbers only at the end of section 12.1, numbers 1 through 63. Please do your work on a separate sheet of paper and then email me a photograph of your work prior to the next class. All right? Okay. Well, I hope that you learned something.